I'd like to talk to you about a general process by which rational equations can be solved. So take, for example, this rational equation. We've got 2 over x squared minus 16 plus 1 over x plus 4 is supposed to equal 3 over x minus 4. Let's see if we can make that happen. Now, the secret to solving rational equations with all these fractions in them is that we're going to try and get rid of the fractions as fast as possible. And so the idea will be to multiply both sides by the least common denominator of these fractions. And then we're going to try and simplify so that all the fractions are gone. Simplify the fractions away. Okay, now if you are going to find the least common denominator of a collection of fractions like this, the first thing you need to do, just like when you're adding the fractions together, is you need to factor all of your denominators so you can see what they already have in common. So, for example, x squared minus 16 can be split as x minus 4, x plus 4. And so, the least common denominator of these three fractions has to consist at least of x minus 4 and x plus 4. And in terms of the least common denominator, that will be big enough to handle these other two denominators as well. So, let's record that. The LCD, the least common denominator of these three fractions, is x minus 4, x plus 4. Now here is the key step, I would say. I'm going to go in and I'm going to rewrite the problem with all of the denominators in factored form. So 2 over x minus 2, x minus 4, x plus 4, 1 over x plus 4, equals 3 over x minus 4. And here is the key. I want to go through one by one, and I'm going to multiply each of the numerators by a copy of the LCD. X minus 4, x plus 4, x minus 4, x plus 4, x minus 4, x plus 4. I'm going to multiply all of these fractions by a copy of the LCD. Hopefully this is all legible. And then I'm going to go through one by one and simplify each of these products. For example, this fraction here on the left-hand side, how would this simplify? Well, you have a multiplied x minus 4, x plus 4. Which can cancel with the entire x minus 4, x plus 4 in the denominator. And if those two cancel each other out, only 2 is left. Now, what about this fraction here in the center? If I have x minus 4 times x plus 4 times 1, and I have an x plus 4 in the denominator, what cancels? What cancels is the common factor of x plus 4, leaving behind 1 times x minus 4, the factors that did not get canceled out. And then finally, 3 times x minus 4 times x plus 4 in the numerator, x minus 4 in the denominator, that common factor of x minus 4 can be canceled out, leaving behind 3 and x plus 4. Now, all the fractions are gone, and I'm left with an equation that's actually linear. So I can solve this by the old-fashioned way. Distribute everything. Distribute. I can solve this by combining like terms. 2 and minus 4 becomes minus 2. I can do this by getting all the x's on one side and getting all the numbers on the other side to give me x take away x is gone. Negative 2 take away 12 is negative 14. 3x take away x is 2x, and 12 take away 12 is gone. So that tells me that x itself would have to be negative 14 divided by 2. X would have to be negative 7. And so, by clearing the fractions, by multiplying both sides of the equation by the least common denominator, by clearing the fractions, we got a linear equation which we could solve the old-fashioned way. Now, the truth is that this is really not technically the final step of this problem. We really should check this answer in the original equation, but we'll deal with that in a separate video.